Hey there, and welcome to this explainer. I am so excited you're joining us today because we are diving straight into a challenge that literally keeps developers up at night, managing complex .NET microservices without, completely losing your mind. Look, breaking a massive, clunky, monolithic application down into sleek, independent microservices is incredibly rewarding. But let's be totally honest with ourselves here. It introduces a terrifying web of network complexity. So let's jump right into this and figure out how to bring some much-needed order to all that chaos.
Picture this for a second. As your application scales up, how are you going to manage 10, 50, or even 100 microservices? Microservices are awesome for scalability and deploying things independently for sure. But the harsh reality is that your client applications now have to somehow figure out how to talk to all these different moving parts. Just imagine a mobile app trying to keep track of dozens of different URLs, handling separate authentication for every single one, and making all these multiple round trips over the network just to load one single page. I mean, it's just a recipe for disaster.
If you actually allow direct client-to-service communication, oh boy, you are looking at pure chaos. It's this harsh, tangled web where just one user request triggers dozens of chatty, synchronous service calls directly from the client. Your latency spikes, simple features start breaking left and right, and the whole system becomes incredibly fragile. But, thankfully, there's a really elegant solution to this, a centralized entry point. Instead of the client needing to know about every single microservice, it just talks to one unified front door.
And that front door? That's your API gateway. By definition, it's a server acting as a reverse proxy that accepts all client requests and then routes them to the appropriate backend services. Think of it kind of like a highly efficient corporate receptionist. You wouldn't just let random visitors wander into a high-rise office building, blindly opening doors, right? You wouldn't want them wandering into the building department asking where the coffee machine is. No way. They have to check in at the front desk first. The receptionist figures out what they need, verifies who they are, and sends them to the exact right floor. The API gateway does the exact same thing, just for your app's incoming traffic.
But here's the thing. This receptionist does some serious heavy lifting. The gateway isn't just mindlessly passing messages along, it is actively managing your traffic. It handles request routing, making sure an order request actually goes to the order service. It balances the load, so no single server ever gets overwhelmed. It even acts like a bouncer, using rate limiting and throttling to protect your services from malicious attacks or those crazy sudden traffic spikes. Plus, it handles SSL termination and normalizes protocols. All of this means your backend services can just put their heads down and focus on doing their specific jobs without worrying about any of these complex networking headaches.
Okay, let's talk about security because this is absolutely crucial. I love this insight from our sources. API gateways can centralize JWT validation, transforming or enriching tokens before forwarding to upstream services. See, instead of forcing every single microservice to independently validate user credentials, which, let's face it, is a massive waste of effort, the gateway steps up as the ultimate security checkpoint. It validates that OAuth2 or JWT token right there at the edge of your network. So by the time a request actually reaches your internal microservice, it's already been completely verified.
So how do we actually build this in the .NET ecosystem? Well, enter YARP, which wonderfully stands for Yet Another Reverse Proxy. Now, do not let that humble name fool you. YARP is a highly customizable, incredibly powerful library that's officially developed and backed by Microsoft. That means it's rock solid for your enterprise apps. It literally lets you build a powerful reverse proxy or API gateway directly inside an ASP.NET Core application.
Now, you might be wondering, why on earth would I build a custom gateway with YARP instead of just buying some off-the-shelf software? Well, YARP gives .NET developers ultimate flexibility. It beautifully hides your internal architecture, sure, but the real magic? The whole shebang is built entirely in C#. That means you get full native integration with the ASP.NET Core middleware you already know and love. If you want to write some custom C# middleware to transform paths, handle weird, unique authentication logic, or inject very specific HTTP headers right at the edge of your network, YARP lets you do that effortlessly.
And honestly, getting started is shockingly simple. Right from your command line, you just run a standard .NET new web to spin up the project, and then a .NET add package yarp.reverseproxy. Boom. In just a few simple lines of code, you have the actual foundation for a highly performant API gateway. It really is that straightforward to get it off the ground.
From there, the configuration is an absolute breeze. When you jump into your program.cs file, wiring it all up takes almost no time. By just calling add reverse proxy and map reverse proxy, you're telling the application to read your routing and cluster configurations, which usually just live right in your standard appsettings.json file, and it instantly starts distributing traffic across your backend API instances. It's clean, it's natively integrated, and it's unbelievably powerful. Okay, pause. We need to shift gears for a second because we have to talk about a major architectural trap. When you hand a developer a centralized tool that is this powerful, it is incredibly tempting to just start stuffing everything into it. Listen to me on this. You must beware the God service.
Let's be crystal clear about what an API gateway should not do under any circumstances. It should never, ever contain your core business logic. If you find yourself writing code in your gateway that calculates shopping cart discounts or processes complex billing rules, you are committing a massive architectural sin called logic leakage. Remember, the gateway coordinates traffic. It's the traffic cop. It does not own the behavior of your application. If you let it turn into a God service, you're going to create tight deployment coupling. Suddenly, you can't update one single service without having to update the gateway too. You'll have essentially rebuilt a monolithic application by accident, just a much more complicated, distributed one.
But if you use it correctly, the gateway is a total lifesaver, especially when you're stuck doing legacy migrations. Have you ever been part of one of those big bang rewrites? Where you switch off the old system, flip the switch on the new one, and literally everyone just holds their breath praying it doesn't crash. Ugh, it is absolutely terrifying. Well, YARP enables something called the Strangler Fig pattern. Here's how it works. You put the gateway right in front of your old legacy monolith. Then, as you build a brand new .NET microservice, say just for the billing module, you simply update the gateway's routing rules. You tell it to send the billing traffic to the new service while everything else keeps happily chugging along to the legacy system. You incrementally strangle out the old system, slice by slice, with almost zero risk. It's brilliant.
Now, as your architecture continues to mature, it's super important to understand exactly where the gateway's job ends. Your API gateway is an edge gateway. It handles all those external clients coming in from the wild internet, validating who they are. But what happens once that request is safely inside your network? When your internal order service needs to suddenly talk to your internal inventory service, the API gateway usually isn't even involved. For secure internal service-to-service communication, you're going to step into the realm of the service mesh. That's where you configure internal routing and mutual TLS encryption using sidecar proxies like Envoy or Dapper.
So I want to leave you with this thought to chew on as we wrap up this explainer. You now know exactly how an API gateway like YARP acts as that absolutely crucial front door, keeping your .NET microservices totally secure and organized. But as your internal services just keep multiplying and talking to each other more and more, will a simple edge gateway be enough, or is a zero-trust service mesh your next necessary frontier? It's a really fascinating evolution to think about, and getting your gateway right today is for sure the absolute best way to prepare for that future tomorrow. Thank you so much for joining me today, and I really hope this brought some serious clarity to your architectural